Hello YouTube. Today we're going to talk about how to implement a basic stack structure with an integer array. First off, we want to initialize the instance variable and the array our stack is using in the constructor. Because we're working with a stack, the top variable will always point at the index of the newest element added to the stack, and therefore we initialize it to -1, which is essentially size minus 1. The size variable, on the other hand, unlike the length variable of arrays, indicates how many elements are currently inside the stack, instead of its total capacity. The first method we're going to look at is the isEmpty method, which checks whether the stack is currently holding any elements inside. To implement this method, we simply need to return size w equals to 0, which returns true if the size variable is 0. That is, the stack does not have any element in its possession currently. The push method here is pretty much analogous to the add method for array lists, but it always adds the element to the end of the array, or the very top of the stack. To implement this method, we have to be conscious of the current size of the stack, and if the stack is full, that is, the size of the stack is equal to the length of the array, we expand the array and then increment both the top and the size variables to keep track of the position of the newest element and the current size of the stack before we eventually append the new element to the top of the stack. The expand method here is basically a private helper method that creates a temporary array with double the size of the original array, copies all the elements from the original array to the temporary array, and then changes the reference of the stack to the temporary array. Since Java has a very convenient garbage collection system, after the change in reference to the temporary array, the original array declared along with the constructor call will be collected so that the memory is not lost in the process. The pop method here is essentially the remove method for stacks. While implementing this, we also have to be mindful of the current size of the stack. If the size of the stack equals to 0, we output a message in the console and return the minimum value of an integer variable, so that the user will be able to tell that something is wrong. If that is not the case, then we first decrement the size variable, and then return the top element and decrement the top variable, again to keep track of where the newest element in the stack is. Do keep in mind that the post decrement for the top variable returns the value of the variable first before it decrements the value. For example, if the top variable has a value of 8, this post decrement would return 8 before reducing the variable to 7. The peek method simply returns the top element in the stack, and if the stack is empty, it also returns the minimum value of an integer variable. The size method returns the current size of the stack, which is basically how many elements are currently inside the stack. Now that we've finished the implementation of the stack, we can try it out with our console. What is being shown here in the main method pushes 5 different int values to the stack, prints the size of the stack, prints the string representation of the current stack before popping 2 values from the stack. It then prints the string representation of the stack value again, prints the current size of the stack, and then checks if the stack is empty or not. Let us run this. And voila, in the console, first off, we pushed 5 elements into the stack, 20, 30, 40, 50, 60. We print out the 2 string representation, and then we pop 60 and 50. And then we print out the string representation again, which gives us 20, 30, 40. And then we print out the size of the stack again, which is 3. And then since the stack contains 3 elements, still contains 3 elements inside, the stack is empty, it returns a false. And that is all the stuff that we're going to be covering today. And thank you for watching.